All right. Today in this video, we're going to look at applying the Pythagorean theorem to to a word problem or to a situation. So we're going to go through two problems. Whenever we're dealing with a word problem involving kind of that Pythagorean theorem idea, I always suggest drawing a picture, drawing that right triangle and making it fit the situation. So how far is a pilot from the airport if he flies 150 miles south and then turns and flies 325 miles east? All right, so I'm going to just draw a picture. I have my pilot. Okay, I think this is the airport. He is flying south and then he is flying east. All right, so he flew south 150 miles. He flies east 325 miles. Now, if we think about it, he flew here, flew this way. Now he's technically at about that point. So the question is, how far is he from the airport? So a lot of times students want to say, oh, 150 plus 325. He's 475 miles from the airport. That would be incorrect. That's how far he's flown. But when we think about how far is he from the airport, it's a direct distance from the airport. And that's where we have our right triangle. This is the actual distance that pilot is from the airport. So now we would take our right triangle, which we can use Pythagorean theorem. So I have two legs, leg, leg. So I'm going to say a squared plus b squared equals c squared. 150 squared plus 325 squared equals c squared. So I'm finding a hypotenuse. I'm going to have to grab a calculator because these numbers are going to get kind of large. So 150 squared, 22,500. 325 squared, 105,625 equals c squared. Add those together. 128,125. And then my last step would be to square root. So we're going to take the square root of that value. And it's about 357.95 miles. So this is the distance the pilot is really away from the airport. Now, if you were trying to get back to the airport and you only have a certain amount of gas, that is something you would want to know and be able to calculate. All right, we're going to look at one more problem, a very common problem, a very common ACT question. Not that you're taking the ACT anytime right now, but it's good to get a head start on that. So let's go ahead and read this one. It says, you want to place a 16-foot ladder against the house. To be safe, you place it 6 feet away from the house and lean it up. How high will the ladder reach? All right. So when we know the length of a ladder, the ladder's what's being, I'm going to draw my picture. So think that's my house, and my ladder is being leaned up against that house. So this is my ladder. The ladder is 16 feet. And they told us it's placed how far away from the house? 6 feet. So I'm always drawing this right triangle, because as soon as I draw and figure out the right triangle in the problem, I can kind of forget about the situation or the word problem itself. I'm focused on the right triangle. So essentially, I'm looking for a leg, right? So I have 6 feet from the house, leaned my ladder up against it. I want to know how high it reached on the house. So in this case, I'm looking for a leg. So now I have a squared plus b squared equals c squared. My ladder is always my hypotenuse. It's leaned up against the house, so that's 16 squared. 6 is a leg. I'm looking for b. So 36 plus b squared equals 16 squared, which is 256. Subtract 36. B squared equals 220. And square root 220. square root, square root. B is about 14.83, and I think we called it feet, so we're going to say feet. So how high will that ladder reach up? It will reach up about 14.83 feet on the house. And that is two examples of using the Pythagorean theorem and applying it to a situation.